During my diploma work, I mostly worked with optical tweezers, optical levitation, so the idea of using optical forces.
This is very complex already.
We'll come to the microscopy, but it's basically the idea to use laser beams to trap small particles and confine them, or in levitation to use optical forces to push particles in liquid along a certain path. And if you use multiple beams, you can confine something, you can rotate it with some tricks, and you can move it around. And my initial task in my PhD project was in the context of a multi-lens microscope where we had 4 objective lenses and a tetrahedron to use these laser forces to move an object around. And it did work to some extent, but the microscope was very complex and very difficult to use. And it was very difficult to also put the sample into the microscope, which I didn't really like. And in that context, it became interesting to study the question, what information can you gain if you have multiple objective lenses and you can look at an object from different sides? And it became very quickly apparent that, of course, as soon as the object is larger than your penetration depth, like how deep you can look into the specimen, having multiple views allows you to reconstruct the sample in a much better quality. And at that time, we just wanted to use 4 fixed objective lenses, but then the idea was born to build a separate setup, small setup, where you could simply rotate the specimen and look at it from different sides. And if you had a fluorescently labeled sample and you would just illuminate it broadly, then what you're missing is this optical sectioning, the ability to look at individual planes in the specimen. And for some reason, then this idea was born to use a slit or a cylindrical lens to confine the excitation light to a narrow sheet and put the object into this sheet so that you see only one plane. And again, the main idea was this, what is now known as multi-view fusion, where you have multiple views that you fuse to reconstruct an object. But with this light sheet idea, it became quickly apparent that it allowed us to give a lot of these image features that you typically know from confocal microscopy or two-photon microscopy, which is namely optical sectioning and the ability to acquire a 3-dimensional image of the object. And then it turned out that this is incredibly fast using a camera rather than doing the point scanning like you do in a confocal. And then having the ability to rotate the specimen was yet another benefit. Because of the speed, we had the time to rotate the specimen and image it from different sides. And yeah, that's basically how the light sheet microscope then was born. It's not an idea that was brand new. It's something that people had done 100 years ago, but not in life sciences, and only in like colloidal sciences to visualize particles in a liquid or particles in a crystal or a glass. And so this was the first time this was really applied to live specimens.